Okay. Last day of review for Trig. Last day of review. We only have 10 problems left. So I think we are going to, oh, I'm delayed. You see that? I'm delayed. Okay, we'll see how that works. 10 problems left, so we're just going to work front to back rather than going like 10, 9, 8, blah, blah, blah. So work front to back. Number 1. So these are all like the advanced algebra stuff still. Simplify without using a calculator. That means do not give me a decimal. Can you add them together if they don't have the same like root in the back? No. So then we just circle that and that's the answer. No. No. What do you do? Break it down. 48 will break down. Really delayed. Sorry. 48 will break down into what and what? What goes into 48? They can take the perfect square root of. Think big. Really, when you're looking at this problem, I want to be able to add them together at the end, so it would make sense if what's left over ends up being a square root of 3, right? That would make sense. So let's try 3. And is there something else that goes into 48? 16. Oh, beautiful. Look at that. Okay, so I'm using my like clues to figure out what that is. 16 and 3. If I take the square root of both, that will be 4 square roots of 3. So this is 4 square roots of 3, and then I'm just subtracting. 11 square roots of 3 minus 4 square roots of 3 is something. 7. Does the square root of 3 stay as the square root of 3? Yep. There you go. 7 square roots of 3. That's it. Okay. All right. Now these ugly things. Simplify. What are you going to do first to simplify this? I really don't like that this is delayed. I can't see what's going on. Simplify. What are you going to take care of first? Distribute the square, right? Okay. Now, the biggest thing that you'll make a mistake on is you'll distribute it for the variables. Make sure you distribute it for the number as well in the front. So this will become 2 squared. Okay. So let's just go ahead and change it to 4. Then it will be x to what? The 6th power, and then y to the negative 6th power. Okay. When you're doing them like that, you distribute and you multiply the exponents, right? When do you add the exponents? I'll put my little rule off to the side. When do you add? This is multiply. That's x to the 6th power. What does it look like when you add the two exponents together? Do you remember? Yep, x to the 2nd times x to the 3rd. That's x to the 5th. That's when you add. So when they're side by side like that, you add the exponents, but if they're stair-stepped, like you're taking an exponent and another exponent, then you multiply those, okay? On the bottom, let's just leave him for right now. 6x to the negative 3rd, y to the 5th, okay? And now let's start simplifying some things, okay? So start with the numbers. 4 and 6 become 2 and 3. Great. The x's. Okay, I have 6 on the top and a negative 3 on the bottom. How do I combine them when one of them is a negative?
Multiply by on top. I don't know.
Okay, how do you get rid of the negative exponent? You're right. You bump him to the top, okay, and he will become x to the positive 3rd power. So now he's that, okay? So I want to combine the x to the positive 3rd power and x to the positive 6th power. What would that make? Is it 9 or 18? 9, because you're adding. There's 2 x's, right? That's kind of like that rule that we had off to the side. X to the 9th power. Okay, y to the 11th. Y to the 6th is going to go to the bottom, and it's going to become positive, so that becomes y to the 11th. Are we done? Yes, we're done. That's it. Okay, good? All right, number 11. How long will it take to double an investment of $300 at 5% interest compounded continuously? Do you remember what continuous compound equation looked like? PERT. That is the PERT equation. A equals PE to the RT power. PERT. Oops, that doesn't look like a T. Okay. How long will it take to double an investment? Where does the $300 go? Where does 300 go? I'm going to change this so it's not fuzzy. There we go. Where does 300 go? P is the principal amount, 300. E stays E. E is just a number, right? 5% goes in for the rate, but you put it as a decimal, so 0.05. And then t is what we're solving for, so we leave that as time, but then I have to know what a is, right? I can't have two variables at once. What is a going to be? Yeah, 600. We're doubling it, right? It has to become 600. Okay? So, what do you want to do first? What? What do you want to do first?
300.
Divide 300. Great. Divide 300, divide 300. Now, if you are doubling an investment, this number should always end up being 2, right? 600 divided by 300 is 2. Okay, regardless of what I start with, that should be 2. E to the 0.05t, and then what? ln. What gets rid of E? ln. We're going to ln both sides. So ln and E cross out. So I've got ln 2 equals 0.05t, and then what? One more step. Divide by 0.05. T is equal to ln of 2 divided by 0.05. Got to be somebody else. I have Allison's calculator. 13.9. Okay, what did we just solve for? What? That's what? Years, right? That's how many years it will take for that investment to double. That seems pretty appropriate.
How do you know it's years, though?
What?
How do you know that that's years?
Compound continuously, that equation is set up so that your time is always in the units of years.
Okay.
Yep.
So
Continuous
it's-
compounding is set up annually.
Alright.
Yeah. Good question. Yep. I will only do continuous. Yep. For, I don't think I asked you like a simple interest or a compounded quarterly or whatever. I won't ask you that equation. Nope. Okay. All right. Properties of logs. 2 more things on logs. Solve for log of 4x equals 2. What is the base of that log if there's nothing there? 10. Log base 10. Okay. How do I get rid of that, or how do I solve this thing? By using the properties of logs. There's a couple different ways I could do this. I want to get to the x, but the x is trapped inside of a log. There's not a log on both sides that we can cross out. What?
Square root of 10 is the 2, or is that 2 to the 4x?
No. You were right. I think about logs in terms of exponential functions. So like log base 2 of 8 equals 3. That written as an exponential function is 2 to the 3rd power equals 8, right? The first number stays in the same spot, second number switch. Okay? So if you have a log on one side, what? Blah, blah, blah. If you have a log on one side and not on the other, just switch it to an exponential function, right? So the base of this exponential function, the first number stays in the same spot, that's 10. Second two numbers switch. 10 to the 2nd power, that's what Josh said, equals 4x, right? And 10 to the 2nd power is 100. And then what? Divide by 4, so x is 25, okay? Now, you can check that in your calculator really easily. Just plug 25 in for x, so you would just take log of 4 times 25, and it should be equal to 2. Just to check your answer. Yeah? Perfect. Okay? There you go. Number 5, write this as a single logarithm. So there's not an equal sign, we're just trying to simplify. Okay? So I see a minus sign. What does minus mean in log world? Not minus. Divide. Minus means divide. Cassidy, got it? Minus means divide. What is multiply? What do they use for the symbol for multiply? You guys are really quiet. Add. Multiply, add. So we want to combine these two. They're both ln's, so I can combine them, except there's a 2 out in front of here, and I want to get rid of him before I do anything. Where can that 2 go? To the back. To the back. So he's going to bump back there. So I have ln of x minus 3 squared minus ln of 4. And I'm going to combine them into 1. So the ln stays. He's going to combine into 1. And we're going to have a big, long thing going on here. What's it going to look like inside of there? Kind of. No, not a cubic function. Minus means divide. You can just leave it as x minus 3 squared. You don't have to multiply that. If you do, that's fine. That's fine. What? Divide by 4x. Yep. That's what he looks like as one single log.
And you take that, so we don't get any farther.
You don't have to go any further than that because we don't know what x is. So you can't evaluate it or anything. So this is it. This is written as one single log, and that is all. Right? Okay. They're just wanting you in this problem to see if you know the properties. Like the 2 can go to the back, and minus means divide. Now on the test, I might do a plus, and that's just multiply. So you'll just write it multiplied instead of divided, right? Okay. So there's that. Number 6, change 5 pi over 2 to degrees. On the test, I might do from degrees to radians instead. Can you do both of them? Right? What's the conversion? 180 over pi or pi over 180, depending on which one I give you. Okay? You're going to use, for this one, you're going to use just what Allison said, 180 over pi, because you want the pi's to cancel. My algebra kids are doing this right now. It's like, it's stoichiometry. You want inches to cancel with inches. So you put one on the top and one on the bottom. Pi's cancel with pi's. Okay, what else would reduce? 90. 5 and 90 multiplied together. There's nothing else on the bottom. 5 and 90 multiplied together. 450 degrees is what that is now. Okay. On the test, just a warning, I might make you go from degrees to radians, but that's pretty easy. Give the angle measure represented by 2 rotations counterclockwise, or clockwise, clockwise. Clockwise goes this way. So 2, there's 1, there's 2. Okay? So we're going around clockwise. We want to know where that will end up or how many degrees that is. Okay? So what's 1 rotation clockwise? 360, but it's clockwise, so that it is negative 360. So 2 rotations would be negative 720 degrees, right? Okay, so basically a way of thinking about this is 2 times negative 360 because it's clockwise, okay? Let's say I had like 1.5 rotations clockwise. You would just say 1.5 times negative 360, right? Okay, and just make sure that if I say clockwise, it's negative. If it's counterclockwise, it's positive, yeah? So negative 720, pretty easy. Okay, identify all angles that are coterminal with 11 degrees. Okay, they want all angles, every single angle. How many angles are coterminal with 11 degrees? If you keep adding 360 and adding 360 and adding 360 and adding 360 and adding 360, there's like an infinite number of angles that are coterminal with 11 degrees. And then you subtract 360 and there's an infinite number of those. So how do I represent all of them? Yeah, the K thing. So I'm going to start with 11 degrees, and then I plus 360K. Now, do I have to put minus? No. K, if we consider K to be an integer. So if K is a negative number, that would be like minus in 360, right? Okay. So that represents every single one of them, and then they want one positive and one negative, right? So 11 degrees, this is how I have my algebra kids do it. Plus 360 and minus 360. This is like their visual aid here, right? If you want to do it that way, I don't care. So if I add 360, what would that be? 371 degrees. Okay, that's coterminal. That's a positive one. The negative one would be, negative 349, maybe. There's my positive and negative one. What? We want it to be negative. We want one positive, one negative. Yeah. So negative 349 and positive 711 or 371. Good. One positive, one negative, and then this is representing all of them. All right. Find the measure of the reference angle for 227 degrees. Do you know what a reference angle is? Reference angle? No. 227 degrees. Where does he live? Third quadrant, down here. He's all the way around. 227 is around down there somewhere, okay? Now, if I make that into a triangle, where do you connect it? To the x-axis. Bow ties, not hourglasses. I'm teaching my algebra kids that also. There's my 90-degree angle. Your reference angle is whatever this guy is, right here. This little angle of that triangle that I'm wanting to know, like the acute angle. So 227 is from here all the way around. How do I figure out what that little triangle inside of there is? How do I figure out what that is? 227 minus 180. Because 180 is just from here to here. So that would be like 47 degrees. Is that acute angle? Now, will you always be subtracting 180? No. If it's like, let's say in the third quadrant, like let's say maybe it's like, I don't know, 300, let's say 300 degrees. Okay, I make that triangle over there, 300 degrees. Okay, I want to know what this angle is. What's that angle going to be? You're not subtracting 180 that time. Yeah, it's going to be 60. Reference angles are never negative. Good point, though. So 60 degrees is what this guy would be because it's going to be whatever it takes to finish him off to 360. So in that case, you're doing 360 minus 300, and that will give you your reference angle, okay? So reference angles are never negative. I'm going to write that in here. Reference angles, never negative. Okay? Okay, reference angles are never negative. Good, good? Yeah, last one. Woo! This is going to be short. All right, last one. Find the values of sine, cosine, and tangent of this angle, A, just of angle A. Why are we allowed to use sine, cosine, and tangent for this triangle? Because it's a right triangle. Yep. Angle C has a little box in him. If you can't really see him very well, you can mark him darker. But we have 60, 80, and something else. 60, 80, something else. How do we figure out the third one? Pythagorean theorem. Yep. That's the side C that we're trying to find. So 60 squared plus 80 squared equals C squared. This is 3600 plus 6400 equals C squared. 3600 plus 6400 is like 100,000. Yeah, 100,000 equals C squared. So what's C? 100. It should be 100. No, wait a second. What did I do wrong? No, it's 100,000. No, it's not. What am I doing? What am I doing? Look at where my comma is. Check out my comma situation here. I'm like, that's right, there should be 4 zeros, but I put my comma in the wrong spot. Blah. So you're right, it is only 10,000, but my comma was in the wrong spot. So there we go. 4 zeros. When you take the square root of something that has 4 zeros, it only has 2 zeros, so 100. Now, we want sine of A, cosine of A, tangent of A. Just those 3, not all 6. When you do the fractions, sine A, cosine A, tangent A, you're going to have to reduce them. And I don't want to reduce 3 times, so what's better is to reduce them as they are right here. Okay, so I can knock off a 0, I know, at least, right, to make that 6, 8, 10, but those will reduce even more than that. Divided by 2. That is a 3, 4, 5. Okay? Now, you technically could have reduced the 3 and the 4, or like the 60 and the 80 before you did the Pythagorean theorem, and then maybe you didn't have to do it, right? If you know that that's 3 and 4, you know that the other one has to be 5. So, if you reduce that to start with, then maybe that would have saved you some work. So, we're looking at angle A. Sine, people kind of get confused when this triangle is laying like some other direction, like it's laying on its hypotenuse side, so don't let that confuse you. Sine, opposite hypotenuse. 3 over 5. Cosine, adjacent hypotenuse. 4 over 5. Tangent, opposite adjacent. 3 over 4. And that is all. Good? Anything else? Beautiful. Beautiful, beautiful.